Welcome to the fascinating world of thermodynamics. Here, we delve into the science that explains how heat, energy, and matter interact. Thermodynamics is the branch of physical science that deals with the relations between heat and other forms of energy. In essence, it determines how energy moves through systems and transforms from one form to another. Why is thermodynamics important? It's fundamental to understanding the physical universe. Without it, we wouldn't develop efficient engines, understand atmospheric processes, or appreciate the energy balance within ecosystems. It's the bedrock of modern science and engineering. In this series, we'll explore the core laws of thermodynamics: the zeroth law, which sets the groundwork for thermal equilibrium; the first law, introducing the conservation of energy; the second law, delving into entropy; and the third law, exploring the behavior of systems as they approach absolute zero. Sit back and prepare to embark on a journey of discovery. We'll navigate the complexities of thermodynamic principles, making them clear, engaging, and applicable to real-world scenarios. As we move forward, you'll start to see how these fundamental laws shape everything from basic heat engines to the intricate climate systems sustaining life on Earth. Welcome to our journey into the world of thermodynamics, where we explore the fundamental principles governing heat, energy, and matter. Let's start with the zeroth law of thermodynamics. This foundational law sets the stage for understanding thermal equilibrium. It states that if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. Imagine a thermometer placed in a container of water. If both thermometers read the same temperature, all systems, the water and both thermometers, are in thermal equilibrium. This concept is critical as it underpins our understanding of temperature and heat transfer. Think about hot coffee cooling down to room temperature. Both your coffee and the room eventually reach a state of balance. Understanding thermal equilibrium helps us navigate more advanced laws. So now that we grasp the zeroth law, let's move forward into the fascinating dynamics of energy conservation with the first law of thermodynamics. Welcome to the first law of thermodynamics, a fundamental principle forming the bedrock of energy science. Often called the law of energy conservation, it states that energy cannot be created or destroyed, only transformed from one form to another. It highlights how energy is conserved within a system through various transactions. This core idea shapes our understanding of physical processes and drives innovations in technology and efficiency improvements. Reflecting on energy conservation, we see its practical implications in how engines convert fuel into motion or batteries store energy for later use. As we move forward, you'll see how energy transformations become more intricate with the introduction of entropy in the second law of thermodynamics. Join us as we continue to unravel the mysteries of thermodynamics, one law at a time. The second law of thermodynamics introduces the essential concept of entropy, which measures the degree of disorder within a system. This law states that in any natural process, the total entropy of a system will either increase or remain unchanged, but it never decreases. This tendency towards increased entropy explains why certain processes are irreversible. For example, once a piece of ice melts into water, it cannot spontaneously refreeze into its original form. Entropy drives the direction of natural processes, ensuring that energy disperses and systems evolve towards greater randomness. This principle underpins everything from the gradual cooling of a hot beverage to the vast, ever-expanding universe. You'll see how this law shapes the behavior of energy in various contexts, shedding light on both the chaos and order in our environment. As we delve into the complexities of thermodynamics, we arrive at the third law. This law brings us to the concept of absolute zero. The third law of thermodynamics states that as the temperature of a system approaches absolute zero, the entropy, or disorder, of that system approaches a minimum value. Absolute zero is the theoretical temperature at which particles have minimal thermal motion, effectively ceasing to move. At this point, we gain new insights into the behavior of matter and energy. The implications are profound, influencing areas such as quantum mechanics and cryogenics. Understanding thermodynamics in such extreme conditions opens up new frontiers for scientific discovery and application. from developing supercomputing technologies to advancing medical therapies. The journey of thermodynamics began centuries ago with early observations of heat and work. In the 19th century, Sadi Carnot introduced the concept of the heat engine, laying the foundation for the second law. Rudolf Clausius formulated the concept of entropy, explaining the irreversible nature of energy processes. William Thomson, or Lord Kelvin, defined the absolute scale of temperature and introduced the concept of absolute zero. Each scientist built upon their predecessor's work, establishing the core principles we recognize today. These milestones marked significant advances in science and shaped how we harness and apply energy in diverse fields. Reflecting on these pioneering minds, we gain a deeper appreciation for the evolution of thermodynamics and its impact on modern applications and advancements. Every day, thermodynamics works around us. In our homes, appliances like refrigerators and air conditioners rely on thermodynamic principles to keep our living spaces comfortable. Refrigerators use the vapor compression cycle to transfer heat from inside to outside, keeping our food fresh. When we step outside, thermodynamics continues to play a crucial role. The engines in our cars, whether powered by gasoline or electricity, convert heat into work. Even trains, airplanes, and ships owe their operation to these principles. Looking at the bigger picture, thermodynamics is key in producing the energy that powers our modern world. From fossil fuels to renewable sources like solar and wind, the conversion of energy forms is dictated by the laws of thermodynamics. As we move forward, you'll discover more fascinating applications of thermodynamics, enriching our knowledge and fueling innovation and efficiency in our everyday lives. Thermodynamics in engineering is not merely an academic exercise, but a cornerstone in the design and optimization of systems across diverse fields. In mechanical engineering, thermodynamic principles are imperative for creating efficient engines and machinery. They help engineers evaluate energy transfer, optimize fuel consumption, and enhance performance. In chemical engineering, thermodynamics guides the design and operation of reactors and separation processes. Understanding the energy changes and equilibria within chemical reactions is vital for creating efficient and sustainable processes. In aerospace engineering, thermodynamic principles govern the development of propulsion and thermal protection systems. As we continue, we'll dive deeper into how thermodynamics shapes our world. The journey doesn't end with engineering. Next, we'll explore its influence on the natural world. Thermodynamics governs many natural processes that shape our world. Imagine the water cycle, where evaporation, condensation, and precipitation create complex weather systems. These patterns, from gentle breezes to fierce hurricanes, are driven by the transfer of heat and changes in energy states governed by thermodynamic principles. Ecosystems, such as rainforests and coral reefs, rely on the laws of heat and energy transfer. Whether it's the warming sun nurturing plant life, or the cooler night skies inducing rest, thermodynamics plays a vital role in maintaining the delicate equilibrium of our natural world. Consider the changing seasons, a perfect example of the natural thermodynamic cycle. As we move forward, you'll see how these principles influence nature and extend to innovative technologies, shaping the future of our world. Imagine a world where technology seamlessly integrates with our lives, powered by the principles of thermodynamics. From rooftop solar panels harnessing renewable energy to nanotechnology revolutionizing medicine, the science of heat, energy, and matter is at the heart of these advancements. Consider modern computing, where managing heat is crucial for efficiency and performance. Thermodynamics drives these innovations and ensures their sustainability. Renewable energy systems convert sunlight into electricity, providing clean power, while nanotechnology relies on precise thermal control for breakthroughs in healthcare and materials science. Efficient thermal management is key to advancing faster, more reliable processors. Understanding and harnessing thermodynamic principles can solve the world's pressing challenges, transforming our homes and tools. Stay with us as we continue this journey, uncovering the profound impact of thermodynamics in our daily lives. As we explore the universe, thermodynamics presents both challenges and opportunities for future research and innovation. One challenge is understanding and manipulating energy transformations with greater efficiency, especially in renewable energy and advanced computing. The unpredictability of complex systems also poses significant hurdles. Future research aims to make groundbreaking advancements in materials that push traditional thermodynamics boundaries, quantum heat engines defying classical limits, and predictive models driven by artificial intelligence. Potential innovations stretch beyond academia into practical applications. Imagine homes powered by efficient, bio-inspired thermodynamic systems or nanotechnology enabling unprecedented control over heat and energy at microscopic levels. Thermodynamics, rooted in centuries-old principles, remains ever-evolving. Each challenge opens new doors for discovery, bringing us closer to mastering the fundamental forces that govern our world. Let's recap the fundamental laws of thermodynamics. The zeroth law, focusing on thermal equilibrium. The first law, highlighting energy conservation. The second law, addressing entropy. And the third law, concerning the approach to absolute zero. These principles provide a framework for understanding the behavior of energy and matter. As you delve deeper into the field, you'll see their profound implications on both theoretical and practical levels. Stay tuned as we further explore how these laws influence our world and pave the way for future innovations. The principles of thermodynamics extend beyond textbooks, impacting technology, the environment, and society. These laws shape devices we use daily, from smartphones to power plants. They guide environmental policies towards sustainable energy solutions and enhance our understanding of natural processes, empowering innovations that improve our quality of life. As we journey through these principles, it's clear that thermodynamics is integral to our past, present, and future. The next time you adjust your thermostat or start your car, remember the profound science at work behind these actions. In our final segment, let's delve into the realm of thermodynamics with insights from leading experts. They share their perspectives on the future of this crucial field and offer invaluable advice for students and aspiring scientists. Listen as they discuss upcoming trends, significant challenges, and the exciting potential for groundbreaking discoveries. Their wisdom will broaden your understanding and inspire the next generation of scientific explorers. Their journey of learning thermodynamics is an ongoing adventure. Stay curious and keep pushing the boundaries of what we know. Thank you for watching, and keep exploring the fascinating world of thermodynamics. Thank you for joining us on this enlightening journey through thermodynamics. Your curiosity has taken you through the fundamental laws governing our universe. But this is just the beginning. We encourage you to dive deeper, explore further, and unravel more mysteries in this fascinating field. We've compiled a list of resources in the video description to aid your quest. They are your gateway to deeper understanding and practical applications. Remember, every question opens the door to new discoveries. Keep exploring, keep questioning, and never stop learning. Thermodynamics is a journey that never truly ends.